In this video, we are to discuss on the maximum likelihood estimation. Before we discuss on the maximum likelihood estimation, we first understand what is the meaning of likelihood function. So the likelihood function, which is denoted as this, or denoted as theta x1, x2 to xn. The likelihood function is equal to the product sum as irony from 1 to n of any given probability distribution. So the likelihood function is equal to the product sum of any given distribution. And what is this likelihood function? The likelihood function is the function of the parameter accorded. So any parameter you accord to the likelihood function, that parameter becomes the likelihood function when you take the product sum of that distribution. Now, what is the maximum likelihood estimation? The maximum likelihood estimation is just the joint density of a random variable. It's the joint density of a random variable. Just like we have said here, that means if the likelihood function is this, as irony from 1 to n, the joint density becomes f of x theta 1 multiplied by f of x2 multiplied by, it continues like that, to f of x i's and theta. So this becomes our maximum likelihood estimation. Now, how can you obtain the maximum likelihood estimation of any probability distribution? How do you obtain that? There are simple things you need to do. One of them is to take the likelihood function, you take the likelihood function of that distribution. The second thing to do is to take the log, the logarithm. The third one is to differentiate and equate to 0. So this is how we can obtain the maximum likelihood estimation of any given distribution. You take the likelihood function, you take the logarithm of that distribution, you differentiate and you equate to 0. Once you do that, you have succeeded in getting the maximum likelihood. That means all we have just said is can be written as differential of the log of the likelihood function of any distribution with respect to theta, which is equal to 0. So once we do this, we have gotten the maximum likelihood estimation of any given distribution. So we'll take some examples on this so that we understand this concept very well. We'll take some examples. For more on this topic, you need to subscribe to this channel. So, our first question will now be if X follows a Bernoulli distribution with theta parameter and we are given the PDF to be theta x into 1 minus theta into 1 minus x. Of course, we know that x will be equal to 0, 1, and continues. So, find the maximum likelihood estimator for theta, because theta is the parameter here. So we are asked to find the maximum likelihood estimator for theta, given the distribution. Just like we said, for we to obtain the maximum likelihood estimator for any distribution, the first thing we have to do is to take the likelihood function. The next thing is to take the log of that function. Then we differentiate and equate to 0. When we do that, we now get the estimator. For in this case, if our PDF is given as the PDF of the Bernoulli distribution, if it's given as this, the first thing to do is to take the likelihood function. The likelihood function of the given distribution is equal to the product sum as irony from 1 to n of the distribution given. Now, how do we expand this? How do we work with this? It has been explained already. This is equal to, we say our likelihood function will be equal to, we take the product sum of this. The first one will give us theta x1 into 1 minus theta 1 minus x1 multiplied by theta x2, which is the second one, into 1 minus theta 1 minus x2 multiplied by, it continues that way to give us theta xi into 1 minus theta 1 minus xi. So this is what we get. If you take the likelihood function of this, we have take the product sum. The product sum means expanding whatever we have here. It then means that our likelihood function for the given distribution, the parameter theta, can be written as, if we put the whole of this, if we take the product sum of this, which is this, the product sum, this sign signifies the product sum. So if we take the product sum of the whole of this, we get theta summation of xi's as irony from 1 to n into 1 minus theta 1, this becomes n, because if you take the product sum of the constant, you get n times that constant. N summation xi's as irony from 1 to n. So this is what we get. We have succeeded in taking the likelihood function of the given distribution. That is all we get. The next thing to do is to take the log, logarithm of this function. How do we take the log? You now say take the log, logarithm. So if we are taking the log, we have mean our likelihood function of our given distribution is equal to, if we take the log of this, we have, of course, this will give us summation of x times mean theta. If we take the log of this, we have plus n minus summation of x times mean 1 minus theta. So this is what we get as irony from 1 to n. As irony from 1 to n. So this is what we get. For more on this topic, you need to subscribe to this channel. We have succeeded in taking the logarithm of the likelihood function, and it is written like this. The next thing is to take the differential with respect to theta and equate to 0. So we'll take the derivative. So you say take the derivative with respect to theta. So it then means taking the derivative, you can write it as ln f of x theta all over the theta to be equal to, now, to be equal to, if we differentiate this, we have to differentiate this function. If we differentiate this, we get something like this. Summation of xi all over theta as I running from 1 to n. If we differentiate this function, this is what we get. Plus, if we differentiate this function, we get n minus summation of xi as I running from 1 to n all over 1 minus theta. Since we are differentiating with respect to negative theta, we will write negative 1 here, because if we differentiate with respect to this, we have negative 1. So this is it. The next thing to do is to rewrite this properly. So we can write it as the likelihood function all over the theta. We can write this to be summation of xi all over theta. Because of this negative sign, we we'll write negative n minus summation of xi as I running from 1 to n all over 1 minus theta. So the next thing to do is for we to equate this to 0. Once we equate it to 0, we can now get our maximum likely estimate for theta. So we equate the whole of this to 0 as one of the rules for finding the maximum likelihood of any distribution. So for me to do that, we move over to this side of the board. For more on this topic, you need to subscribe to this channel. You need to subscribe to this channel. All right. So the next thing to do is say equating to 0. We can write equate to 0. So equating to 0, we get summation of xi as I running from 1 to n all over theta minus n minus summation of xi all over 1 minus theta to be equal to 0 as I running from 1 to n. So the next thing to do is to cross multiply. We cross multiply. So we have cross multiplying, we have summation of xi as I running from 1 to n into 1 minus theta minus theta into n minus summation of xi's all over. If you take the LCM of this and this, we get theta 1 minus theta to be equal to 0 as I running from 1 to n as I running from 1 to n. So this is what we get. Of course, if we multiply this to give us 0, we can open the bracket to get us. If we open the bracket, we get summation of xi minus theta summation of xi minus n theta plus theta summation of xi as I running from 1 to n as I running from 1 to n as I running from 1 to n. Of course, this is equal to 0. Of course, this will multiply this to give us what? 0. Now, if you watch at this can cancel this. So we left with summation of xi minus n theta to be equal to 0 as I running from 1 to n. Now, we move over to this other side of the board in order for we to get our estimates. Of course, you know we are finding theta. We are looking for theta. So we move over to this side of the board to do that. For more on this topic, you need to subscribe to this channel. Now, this can move over to this other side of the board to give us summation of xi to be equal to n theta. Now, we can make theta the subject of formula. If we make theta the subject of formula, we will have theta estimate to be equal to summation of xi all over n. Of course, we know that summation of xi all over n is equal to our expected value, which is equal to x bar. Then we can now write our theta estimate to be equal to x bar. So this becomes the maximum likelihood estimator for the Bernoulli distribution. So of course we can say this is unbiased. It's an unbiased estimator because this summation of xi all over n is equal to mean. So this is our estimate for the Bernoulli distribution given the parameter theta. We also take another question. We take another question on this. So we have to clean the board. For more on this topic, you need to subscribe to this channel. So we'll take another question. For more on this topic, on minimum likelihood estimator, you need to subscribe to this channel. Our next question, question 2. If x follows a Poisson distribution with parameter theta, and we are given the PDF to be equal to theta x exponential negative theta all over x factorial, where we know that x2 is equal to 1, 2, and continuous 0, 1, 2, and it continues. So find the maximum likelihood estimator of theta. So we have to find the maximum likelihood estimator of theta given the Poisson distribution. Solution. Now, if we are given this as our Poisson distribution, it's very simple. The first thing to do for the maximum likelihood estimation is to take the likelihood function of the given PDS. So the likelihood function of the given Poisson distribution is equal to the product sum as irony from 1 to n, the product sum of f of x, which is, or we can write it as the product sum of theta x exponential negative theta all over x factorial. So all we need to do is to take the product sum of the given distribution. So the product sum can be written as, if you take the product sum of this distribution, that means the Poisson distribution, we have the first one will be theta s1 exponential negative theta all over x1 factorial multiplied by theta x2, the second one, exponential negative theta all over x2 factorial multiplied by, it continues like that to give us theta xi exponential negative theta all over xi factorial. So this is what we get. Now, if you take the product summation of this function, we'll have our likelihood function to be written as theta summation of xi as irony from 1 to n exponential. If you take the sum of this, we have n theta all over summation of xi factorial as irony from 1 to n. So this is what we get. This is exactly what we get. The next thing to do is for we to take the logarithm or the log of this our likelihood function. The next thing to do is to take the log or the logarithm of our likelihood function. So we write here, take the log, take the logarithm. So taking the log, we can write it as mean our likelihood function to be equal to, if we take the log of this, we get summation of xi in theta as irony from 1 to n minus, if you take the log function of an exponent, the exponent will go off. So we write this n theta, n theta. If we now take the log of this, we can write this as minus mean summation of xi factorial as I only from 1 to n. So this is what we get. This is what we get for the Poisson distribution. If we take the logarithm of the likelihood function. Now the next thing to do is to take the derivative. We take the derivative with respect to theta. Once we take the derivative with respect to theta, we can easily get the maximum likelihood estimate for the given distribution. Now, we say take the derivative with respect to theta. We take the derivative with respect to theta. So for me to do that, we move over to this side of the board to do that. For more on this topic, you need to subscribe to this channel. So we take the derivative of this function with respect to theta. It will now give us, we can write it as this f of x all over the theta is equal to, now if we take the derivative of this, we will have summation of xi all over theta. If we take the derivative of this with respect to theta, we get minus n. If you take the derivative of this function, mean summation of xi factorial, we get 0 minus 0. So this can be written as summation of xi all over theta as I running from 1 to n minus n. So we have succeeded in getting the derivative with respect to theta. Now, the next thing to do is to equate to 0. To equate the whole of this to 0. So we say equate to 0. For we to equate this to 0, we can write it as summation of fi all over theta as I running from 1 to n minus n is equal to what? 0. So that is it. That is it. So the next thing to do is to get our estimate. To move over to this side of the board to do that. To get our estimate. Our estimate for theta becomes, we can write this as summation of xi all over theta to be equal to n. Of course, if we cross multiply, we have theta estimate to be equal to summation of xi all over n as I running from 1 to n. As we all know, this is equal to our mean. So we have theta estimate to be equal to x bar, which is our mean. So this becomes our maximum likelihood estimate for the given Poisson distribution. Once we follow these principles or this process, it is quite easy to get the maximum likelihood estimator for any distribution. We take yet another question on maximum likelihood estimation. So if x follows a geometric distribution with p parameter, and we have the PDF to be, if we have the PDF to be this, that is as x running from 1 to infinity, we have to find the maximum likelihood estimator for p. The geometric distribution follows, x follows a geometric distribution with p parameter. The parameter given is p. Now we have solution. Like we all said, the first thing to do is to take the likelihood function of this distribution. But in probability, we should understand that P plus Q is equal to 1, which implies that Q is equal to 1 minus P. So anyhow we see Q, we put 1 minus P. It then means that the PDF can be written as P into 1 minus P x minus 1. So the first thing to do is to take the likelihood function. We say the likelihood. Take the likelihood function. So taking the likelihood function is quite simple. We move over to this other side of the board. So the likelihood function of our given PDF can be written as the likelihood function of our PDF, which is equal to the product sum of the given function. And what is the function? The function is the product sum our likelihood function is the product sum of p into 1 minus p x minus 1. So we take the product sum of this geometric distribution. Taking the product sum, we have the first one is p, which is our first 1 minus p x 1 minus 1 multiplied by the second p into 1 minus p x2 minus 1 multiplied by, it continues like that to give us p n into 1 minus p xi minus 1 xi minus 1. So this is what we got. It then means that we can write our likelihood function to be equal to p raised to the power of n into 1 minus p. So if we sum this, we get, we take the product sum of what we have of all of them. We have summation of xi minus n. Because if you take the product sum of a constant, you get n times that constant. So this is what we get. The next thing to do is to take the log. To take the logarithm. How do we take the log? We write take the logarithm. So we take the logarithm of this function. For me to do that, we'll move over to this side of the board to do it. For more on this topic, you need to subscribe to this channel. So we've written take the logarithm. Taking the log, we write it as li. Our likelihood function of the given PDF will be equal to, we take the log of this, we have n li p plus, if we take the log of this function, we have summation of xi minus n all over 1 Well, if you take the log of this, we have summation of xi minus n mean 1 minus e as I running from 1 to n. So this is what we get. This is what we get. The next thing to do is to take the derivative with respect to p. We take the derivative with respect to t. So take the derivative with respect to p. So take it with respect to p because the geometric distribution we are given has the parameter p. Now, if we take the derivative of this function, we can write it as with respect to p to be equal to, if we differentiate this with respect to p, we have m all over p. This is what we get. Now, if we differentiate this with respect to p, we have plus, which is this sign, summation of si all over n all over 1 minus p. Since you are differentiating with respect to p, we will have negative 1 as I running from 1 to n. So we can rewrite this properly because of this negative sign. We can write it as the derivative mean our likelihood function of the given distribution with respect to p can be written as n all over p minus summation of xi minus n as I running from 1 to n all over 1 minus p. So we succeeded in writing this out properly. Like we said, from the maximum likelihood estimation, that for we to get the estimate, that is the maximum likelihood estimate, we have to take the likelihood function, we take the logarithm, we take the derivative with respect to the parameter given, and equate to 0. So we equate the whole of this to 0. We write equate to 0, equate to 0. For it to equate to 0, we move over to this side of the board to do that. So move over to this side of the board to do that. So equating to 0, we'll have this as, we can write it as n all over p minus summation of xi minus n all over 1 minus p as I running from 1 to n to be equal to 0. Now we can cross multiply. We can cross multiply. If we cross multiply, we'll have n into 1 minus p minus p into summation of xi minus n all over p into 1 minus p. Of course, if you take the LCM of this and this, you get this. So this already will multiply 0 to become 0. We open this bracket, which will give us n minus np minus p summation xi as I running from 1 to n, as I running from 1 to n, and this multiplied by this, negative p multiplied by negative n, we get plus np to be equal to 0. Of course, this has already multiplied 0. Now, if we watch at the whole of this can cancel this because negative 1 plus 1 is 0. So we are left with n minus p summation of xi to be equal to 0. Of course, we can write this as n to be equal to p summation of xi. If you recall, we are trying to estimate p. We are asked to estimate p in this geometric what distribution. So for me to do that, we'll move over to this side. So we have to make p the subject of formula to see what we have. To make p the subject of formula, making p the subject of formula, we'll have to rewrite it here. Write it out properly here. For more on this topic, you need to subscribe to this channel. For more on this topic, you need to subscribe to this channel. Now, making p the subject of formula, we'll have p to be equal to n all over summation of xi as I running from 1 to n. So this becomes our estimate. Of course, this is biased. And we can write this as 1 all over x bar. Because our mean already is supposed to be summation of xi all over n. So since we have the opposite, we'll write 1 all over x bar. It then means that our p estimates the maximum likelihood estimator of p given the geometric distribution is 1 all over x bar. 1 all over mean. Of course, this estimate is biased. The estimate is biased. Our maximum likelihood estimate is biased. So this is simply how we can obtain the maximum likelihood estimate for P given the geometric distribution. We take yet another question. We take yet another question, this time on exponential distribution. On exponential distribution. So we play the ball to take another question. For more on this topic, you need to subscribe to this channel. Now, if this is our question, if x follows an exponential distribution with parameter theta, given the PDF, if our PDF is given as 1 all over theta exponential negative x all over theta as x is greater than 0. Find the maximum likelihood estimator for theta. So we are asked to find the maximum likelihood estimator for theta given the question. Solution. Like we said, to obtain the maximum likelihood estimator for any given distribution, the first thing to do is to find the likelihood function. So if this is our PDF, we first take the likelihood function. We take the likelihood function. The likelihood function for the given PDF can be written as the product sum is equal to the product sum of that distribution. So we can take the product sum as I running from 1 to n, 1 all over theta exponential negative x minus theta, or all over minus x all over theta. So this is what we get. So how do we get the product sum of this? I will show you how to expand the product sum of any given distribution. Expanding it, we can write our likelihood function to be equal to 1 all over theta, which is the first one, exponential negative x1 all over theta multiplied by 1 all over theta. The second one, exponential negative x2 all over theta multiplied by, it continues like that, multiplied by 1 all over theta and exponential negative xi all over theta. So this is what we get. This is what we get. So we can write our likelihood function to be equal to 1 all over, if you take the product sum, if you take the product sum of this, we have this exponential, the product sum of this will have summation of si's as I running from 1 to n all over theta. So this is what we get when we take the product sum of the given distribution. Now the next thing to do is to take the logarithm, is to take the log. Of course, we explain that in our maximum likelihood estimation, that for we to obtain the estimates, we take the likelihood function, the log, the derivative with respect to the parameter given, and equate to 0. So we write take the logarithm. Taking the log, we have the f of x to be equal to, okay, for it to make it easier for us, this can be written as theta minus n exponential negative summation of xi all over theta. That means, let us arrange this first. Our likelihood function can be written as theta negative n exponential negative summation of xi all over theta as I running from 1 to n. Now, we say take the log, take the logarithm, take the logarithm. We move over to this side of the board to do that. For more on this topic, you need to subscribe to this channel. So taking the log, we have our likelihood function of the given distribution to be equal to negative n the theta minus, if we take the log of this function, since it has an exponent, we will have just the whole of this function. So we have negative summation of xi as I running from 1 to n all over theta. So the next thing to do is to take the derivative with respect to theta. The next thing to do is to take the derivative with respect to theta. So we say take the derivative with respect to theta. So we have with respect to theta to be equal to, we take the derivative of this, we have negative n all over theta. If we take the derivative with respect to theta, we'll have negative. Now, by the side, we'll have 1 all over theta, which is theta negative 1. If we take the derivative, we'll have negative theta negative 1 negative 1. So negative theta negative 2, which is negative 1 all over theta squared. So we'll have bracket negative summation of xi as I running from 1 to n all over theta squared. So this is what we get. This is what we get. So we can write this properly to give us the derivative of the f of x all over the theta to be equal to negative n all over theta plus summation of xi as I running from 1 to n all over theta squared. So we equate to 0 equates to 0. We equate the whole of this to 0. We move over to this other side of the board to do that. So we equate to reference to 0. For more on this topic, we need to subscribe to this channel. So equating to 0, we can write it as negative n all over theta plus summation of xi all over theta squared to be equal to 0. So this can be written as negative this to be equal to negative summation of xi as I running from 1 to n all over theta squared. So this will cancel this. We are left with n all over theta is equal to summation of xi all over theta squared. Of course, this can come here to give us theta squared all over theta is equal to summation of xi as I running from 1 to n all over n. So this can cancel this. We can now write the estimate of theta. So we move over to this other side of the board to write the estimate of theta. Move over to this side. For more on this topic, you need to subscribe to this channel. So we can simply write the maximum likelihood estimate of theta. The maximum likelihood estimate of theta will now be theta will be equal to summation of xi all over n as I running from 1 to n. So this becomes our estimate. Of course, this is mean. So it then means that our theta estimate for the exponential distribution is equal to x bar. Is equal to x bar. So this is simply how we can compute the maximum likelihood estimation for the exponential distribution with theta as the parameter. This is how we can obtain, if we follow all the processes, this is how we can obtain the maximum likelihood estimator for theta given the distribution.